Hi, welcome back to my channel. For today's video, we will learn about relations and functions. So if you are new here, please don't forget to subscribe and click on the bell button for you to be updated on a lot of videos that I'll be uploading soon. So have you been in love? Okay, well, whether you are in a relationship, you're single, or you're in love, or complicated, we can't deny the fact that there is this month called February. And February 14 is fast approaching, so we will talk about love and trust. So for today's video, we will connect our mathematics to the trust and love. So what is really love? Because for me, I used to believe that love is a feeling, but now I know that love is a commitment. Now, I don't know what will be your definition of love is. Whatever you say, I will respect on that. Now, this time, we will learn this one concept in mathematics called relations and functions, and how do we connect this with love. So we have definition of a relation. So what is a relation? So a relation is any set of ordered pairs x, y. So technically, your x here is coming from the first set. Your y is coming from the second set. So to illustrate on this, we will consider a relation of people. So let us say, for example, I have the set x here containing the names of male persons. I have Mario, I have Mike, I have Jacob, and I have Miguel. I don't know why I come up with these names, but it doesn't matter as long as this set is defined to be the name of male person. I also have here Y with names like Jean, Angel, Gina, and Leah. Okay. Now, suppose Mario is in a relationship with Angel, Mike is in a relationship with Jean, Jacob is in a relationship with Gina, and Miguel has a secret affair with Angel. So let's assume, for example, here, Angel is a two-timer here. So this is one example of a relation because we can make an ordered pair out from that mapping. Remember that I would have an ordered pair here, Mario, Jean, I have Mike, Angel, I have Jacob, Gina, and I have Miguel, Gina. So this set is a relation. That's it. Okay, so another definition here. This is for the definition of a function. So a function is defined to be a relation such that every element of the first set must be paired to exactly of one element of the second set. So that is a function. So meaning to say that a function is a special type of relations. So one remark would tell us that all functions are relations, but not all relations are functions. That's it. So in order for us to figure this thing out, we will illustrate um, how we deal with function as a relation. But first is, let us consider the abstract picture of the function. A function is like something, a machine. So Here's a function wherein if you input here an x, it provides another, it provides an output here. So technically, whatever you do, let's say for example, let's consider imagining it. We're actually eating. So what we're eating is actually the input. What we excrete is actually the output. So our body is our function, something like that. So if we consider, let's say for example, I have f of x here, defined to have, let's say x squared. If x is even, I'd have x plus 5 here if x is odd. So what happens when x is 2? So when x is 2, so this is even, so I'd use this. So that's gonna be 4. If x is 3, so this is odd, so I'm gonna use this. So I'd have 8. So basically, whatever you put something on it, there is a resulting product after the process. So that would be the function. In this case, it should have that the resulting value corresponds to a unique representation. So that will be the definition of the function. Now, to formally illustrate that on how do we consider that in a relationship, in our Valentine season, let's consider again the set here. Again, I have here Mario, I have names like Jim, I have names like Mike, I have names like Miguel, I have here Jacob. So I have here Althea, Mona, Gina, Angel, Grace. Okay, now in this case, suppose is Mario is being is in a relationship with Althea, Jim is in a relationship with Mona, Mike is in a relationship with Angel, Jacob is with Gina. Now the point of the definition of a function is that every element, so that means it should have to be all of the elements of the first set. So we don't consider the fact that not all of them are single. So because it says here in the definition that every element, so that means the first element or the boys here should not be single. Otherwise, that would disqualify to the definition of a function. So we should have to make sure that Miguel will have a date on the Valentine's Day. So suppose for example, Miguel will have a date for Grace. So that means all of the boys here are taken. So let's take a look. Is Mario mapped to Althea? Very good. So Mario is, in this case, Mario is loyal. So he is only in a relationship with one person. Jim is also loyal, Mike is loyal, Miguel and Jacob are loyal. So in this case, we would have to make sure that boys here, because they belong to the first set, should be loyal to make sure that they are actually following the definition of a function. That's it. So what if, let's suppose for example, Miguel, okay, I think I have a problem with my pen here. Okay. What if, suppose for example, Miguel, okay, is dating Gina, even if Gina is in a relationship with Jacob? Well, that's still a function. Why? Because according to the definition, as long as all boys are taken, so there all these boys here in the first set are taken, assuming that when we say dating that's already in a relationship. So Miguel is in a relationship with Gina, so that's not a problem. They're all taken and they're all loyal. So that means Mario is not in a relationship with anybody else except Althea. So with Jim to Mona, Mike to Angel, Miguel to Gina, and Jacob to Gina. We don't care in this case whether girls, because they belong to the second set, girls should be loyal or not. We don't care about that. Our definition of a function says only we have to take her on the first set. So we don't care about that for as long as the first set are loyal. Now, and we don't care even if Grace here is single. What we care is the first set that all of the boys there should be taken. That is the definition of a function. That's it. So, for the definition of a function, the set of boys here that are being taken, because of course they should be taken to be considered as a qualification for function, this set here is called a domain of the function. Now, this set here, the Y, the names of girls, Althea, Mona, Gina, Angel, and Grace, this set is the codomain. But do we have a name for those who are taken or not? Yes, of course we do. Those who are taken, so except here Grace, this is our range. Meaning to say that the range is only the set of all girls on the second set that are being taken from the first set. So, itong kawawa, walang jowa, this is just a mere element of the codomain but not on the range. That's it. Okay, so in this case, how do we evaluate a function? So say, by evaluating this function, this is, let's say for example, given we have f of x equals x plus 3. So if x is 0, so what do we do is we have f of 0 is equal to, we have to plug in the value for x, which is 0. So 0 plus 3, so I get 3. So therefore, the value of the function at 0 is 3. Meaning to say that when we plug a value to the function becomes constant, no longer an equation. That's it. Now, how do we define or how do we evaluate when a given equation or a given locus is a function or not? So, one perfect test to do that is by the use of vertical line test. So, in this case, we do here as, let's say for example, our f of x is x plus 3. Now, in order for us to identify that f of x is really a function, we do the vertical line test. So if it meets the vertical line test only once, then that will be a function. Otherwise, if it meets more than one, then that's not a function. It's just a mere relation. In order for us to do that, we will have to graph x plus 3. So assuming I have a perfect drawing here. Okay, so x plus 3, when x is 0, I get 3. So that's technically, this is our f of x here. This is our x here. So if x is 0, so probably here. And if x is negative 3, what happened when x is negative 3? Our f of x is 0, so somewhere here. So by just 2 points determine a line, so I can just connect it here because this is an equation of a line. This is a linear equation of degree 1. Remember that x there is the highest degree is 1. So this is a line. So 2 points determine a line. So I just can connect this one here. That's it. And so we will have to do the vertical line test. So let's create a vertical line here. So it meets only one point here. And we don't care that point of intersection as long as it meets here. So therefore, f of x equals x plus 3 is a function. In fact, all linear equations are functions. That's it. Okay, so now that we have done conceptualizing what a function is and what a relation is, and how do we identify when a given relation is a function or not, now we will have to consider types of functions. So first is we start considering an injective function. So in this case, an injective, a function is said to be injective. Some other books would call this as one-to-one function if for every two elements in the first set, say a and b, if f of a is equal to f of b, it implies that a is equal to b. So that means if f of a equals f of b, this implies that A equals B. So if we take the contrapositive of these, for given two sets in the first, two elements in the first set, so we have A and B. If A is not equal to B, we would get f of A not equal to f of B. That's it. Okay, so we will consider an example here. Let us evaluate if a linear function is injective. Okay, in this case, so it's linear function injective. Remember that a function is said to be injective if for every elements in the first set, we have A and B, f of A is equal to f of B, implies A equals B. Now, remember that a linear function can be on the form f of x equals ax plus b, something like that. Okay. Now, so in this case, I'm not gonna use A and B. Instead of using A and B, oh yeah, it's okay. I'm gonna use A and B. So, but this time I'm gonna let elements on the second set. So on the domain, the first set. So let's say M1 and M2 be elements of the first set. So I'm gonna have elements of X. So my f of M1 here is equal to M1 X plus B, right? Okay. And I would also have f of M2 here, so I would have M2X plus B. That's it. Okay. So suppose f of a, suppose f of M1 is equal to f of M2. So meaning to say, suppose M1 plus M1X plus B equals M2X plus B. So remember that B here and here is constant, so I can subtract both sides by B. So I would get M1 X equals M2X. So X is an element of real number, and provided here X is not 0, so I can divide both sides by X. So I'll get M1 equals M2. And so linear functions are one-to-one or injective, because we are actually following the definition that if we assume f of A equals f of B, you should have to have a result A equals B. That's it. Okay, so to illustrate on this, what do we really mean by one-to-one? So if we are going to illustrate the relationship here, so again, I would have names of boys on the first set, so that's gonna be my name, of course. I would love to have a date on the Valentine. So that's Mark, Mike, Miguel, and Arnold. I don't know why I come up with these names. And I have Leah, I have Jean, I have Sean, I have Fred, assuming they're all girls, and Laika. So Mark is paired with Sean, Mike is paired with Fred, Miguel is paired with Leah, Jean is paired with Arnold. So technically, first is we need to identify first if that's a function. Of course, this is a function because number one, all boys are taken. Number two, they're all loyal. They're dating to one person. Now, it is considered as one-to-one in the sense that girls here, remember, you have to, girls here are only paired once. So, girls here are loyal. So that means this is one-to-one. That's it. Okay, so let's consider another type of function. So we call that as surjective function. So as defined, a function is said to be surjective if for every element on the second set, say B, there is this element in the first set, say A, for which f of A is equal to B. So meaning to say that um, all the elements on the second set should be paired to the elements on the first set. Meaning to say, if we have the set for boys, we have the set for girls, walang girls ang single. They should have dates on Valentine's Day. That's the point of surjective function. By the way, surjective is sometimes called onto function. That's it. Okay, so let us consider an example here. We will have to evaluate if a linear function is surjective. So is linear function surjective? Now remember that our f of x, the function, is equal to mx plus b. So our f here is defined as mapping from x to y. Okay, so if we let y, element of the second set, we assume x here equals, I would have y minus b over m. So remember that if I'm going to take f of x equals, I have m times y minus b over m plus b, that will be equal to y. So meaning to say that f of x is equal to y, so therefore that's surjective. Because according to the definition, you just have to find a value, or I mean an element on the first set that can be paired to the element on the second set. So all elements on the second set should have a value, a corresponding element to the first set. That's it. Okay, so last type of function is bijective, or as a function is said to be bijective if it's both injective and surjective at the same time. So earlier we have shown that a linear function is it's bijective in the sense that it is injective and surjective at the same time. So that's the reason why it's bijective function. Okay, now we have covered the intuitive definition of relations and functions. So to recall on that, I hope you would realize that that actually exists in the world today, that a function, so if we have a set of boys in the first set of girls in the second set, so in order for us to see the relation as function, all boys, number one, are taken. Number two, they should be loyal to their partner. Okay. Okay, next is injective. So for a function to be injective, you have to look on the second set. The girls should be loyal to their partners. Second is surjective. So that's on to function. So the girls, all girls are taken. So when we say bijective, we have the peace and harmonious relationship everyone is dreaming about. So I hope you learned a lot today for this video, and I hope you all will have dates this Valentine's Day. Thank you so much for watching. And again, my name is Mark, and if you are new to my channel, please don't forget to subscribe and click on the bell button for you to be updated on a lot of videos that I'll be uploading so soon. Thank you so much and have a great day.